before we continue with our normal lessons, I gave you a past paper which is Physics 2009. So I'll try and go through questions, I think today and tomorrow. Then on Friday we shall continue with our normal lessons. So starting from number 1, so we are finding acceleration. So for this one, we definitely know that this guy starts from rest. So we can definitely collect our data. So starts here from rest, so that means our initial velocity is 0 meters per second. Then what is your final velocity? 25. So v is equal to 25 meters per second. Then what's our t? T is equal to 20 seconds. That's our t. Then a, that is what we are finding. So definitely we know that acceleration a is equal to v minus u over t. So we know our final velocity, we know our initial velocity, and we know our t. So v is a 25, so it's a 25 minus 0. 25 minus 0 divided by time is 20. So 25 minus 0 divided by 20. Therefore 25 minus 0 is just equal to 25, of course. So it's 25 divided by 20. 25 divided by 20. So 20. So you don't really have to find using such big numbers. You can just reduce them. So how do we reduce them? So we look for a number which goes into this and that. The largest, of course. So definitely it's a 5. So 5 into 25, that's a 5. 5 into 20, that's a 4. So it's 5 over 4. Therefore, we say 4 into 5, that's a 1. Remainder 1. So you put a point there. So you can just do the grade 1 mark of saying 0.5 there, 1, remainder 1. 4 into 1, that's a 0, of course. Then point 4 into 10, that's a 2. Remainder a 2. Like that. Again, like a 2 there. Then 4 into 20, of course, that's a 5. That means it's 1.25 meters per square second. 1.25 meters per square second. That's what you have here. That's your acceleration in the first 20 seconds. That is your acceleration in the first 20 seconds. That's your acceleration in the first 20 seconds. So we can just go back to the first board so that we can see where this guy started from. Like that. Then the last part. So if you don't have the questions, it's Physics 2009. So it's saying the mass of the car was 1,200 kg. So we are finding the force which produced the acceleration in A1. So of course this is B. So what are we finding? We are finding force. So force is unknown, of course. Then what's our mass? Our mass has been given as 1,200 kg. What's our acceleration? Our acceleration is 1.25 meters per square second. So mind you, mass must be in kg and acceleration must be in meters per second squared, like that. So definitely we can use our formula of this guy. So we know a force is equal to mass by acceleration. Force is equal to ma. What's our mass? Our mass is a 1200. Then A is equal to 1.25. 1.25. That's our acceleration. So therefore 1200 by 1.25, that's 1500. That's 1500 newtons. That's the force. 1500 newtons. That's your force which produced this acceleration. That's the force which produced this acceleration, like that. So one last glance at this, then we solve the last one on number 1. We solve the last one on the first one. So let's go to C. C is saying find distance covered, of course, in the first 20 seconds. Now, I'll use 2 ways of solving this. So, what do you know? Distance is equal to area under the graph. That's your D, of course. Distance is equal to area, this, like that. So this is a triangle. This is a triangle, of course. So what do we know? Area of a triangle is equal to what? Half BH. So method 1. Area is equal to half BH. So half by base is a 20. 20 by this side is your velocity or your speed, of course, which is a 25. So therefore 2 into 20, that's a 10. So it's 10 by 25, which is equal to 250 meters. That's method 1, 250 meters. So I've used area under the graph, which is equal to the distance. Then when it's a triangle, you can also use the other method of so let me just show you the other method that you guys can use. But this one is the best and the easiest. So let me just show you the other method on the other side. Let me just show you the other method. So going to the other side, what do we know? Let's have what is given and what we found. So initial velocity is a 0, final velocity is a 25, time is a 20. So we know S is equal to V plus U over T, over 2 rather, by T. Therefore, what do we have? It's a V is a 25, so 25 plus 0 divided by 2. Time, of course, is a 20. So it's 2 into 20, that's a 10. So it's a 25 by 10 again, which is also a 250 meters. That's the second method, method 2. So method 2 we've used the formula, and method 1 we've used area under the graph. Then if you love school so much, you can also use method 3, of which it says S is equal to UT plus half AT squared. UT plus half AT squared. UT plus half AT squared. So we know our initial velocity is a 0. So this will just give you a 0, of course. This will just give you a 0. So 0 by 20, of course, plus half. Acceleration is a 1.25 by, of course, time is 20 squared. 20 squared, of course. Yeah, something like that. So this will just give you a 0. So it's just half times 1.25 times 20 squared. That's just equal to a 400. That's just equal to a 400. So if you do some math there, half by 1.25 by 400, that will just give you a 250. So you can just confirm that. So you can just say 2 into 400, that's a 200. 200 by this guy, that will definitely give you a 250 anyway. 250 meters, that will be your answer. So I've used 3 methods. I have used 3 methods. So you can just use any of these methods, depending on which one you are comfortable with. But my advice is that you can use the first one. Finding area is the best formula that you can ever use. So you have a rectangle, you can have a square, you might have a trapezium, or you might have a triangle. That is what you guys use. Like that. So let's solve the next step. So let's solve number 2. So a girl who has a mass of 50 kg runs up some stairs in 7 seconds. The stairs are 8 meters high. Take G as 10. So let's just get our data, of course. That's the most important thing. Let's just get our data. So what we have, they're saying, so this is number 2, of course. What's the mass of the girl? So the mass of the girl is a 50 kg. Then runs up in 7 seconds. So time, of course, is 7 seconds. Then the stairs are each 8 meters. They are 8 meters high rather. So height is equal to 8 meters. Then what's our G? Our G is a 10. G, of course, is a 10 newtons per kg. 10 newtons per kg. So we are finding the girl's weight. So finding the girl's weight is easy and straightforward. What do we know? We know that for the first one, weight is equal to mg. Our mass, of course, is a 50 by our G, of course, is a 10. That's equal to 500 newtons. That's the weight. 50 by 10, that's a 500 newtons. That's the girl's weight. That is the girl's weight. Then next, the girl's potential energy. The girl's potential energy. So we know PE is equal to mgh. So PE is equal to mgh. What's our mass? Our mass of course is a 50. What's our G? Our G of course is a 10. What's our height? Our height of course is an 8. So it's 500 by 8, which is equal to 4,000. So it's 4,000 joules. That's your PE. So our mass is a 50, our G is a 10, then our height definitely will be an 8. So 50 by 10 by 8, that's equal to a 4,000 joules. So let's go to the next one. So we are finding the power output. So definitely power output. So let's just go the other side so that we just change the scale. So power is equal to energy over time. P is equal to E over T. P power is equal to energy over time. So what's our energy? Our energy is a 4,000 joules. Then our time is 7 seconds. So it's 4,000 joules divided by 7 seconds. 4,000 divided by 7 seconds. So definitely if you use a calculator, you find something like a 551.4285. 571.4285. So therefore it's just 571.43 watts. So like we know this 8 is more than 5, so you add 1 to the 2 to give you of course your 3. So 51.43. 51.43. 51.43. That's the answer for this one. So definitely gone through number 1 and number 2. So the next one is on Brownian motion. So definitely if you've been going through our lessons, we just did this area. We looked at this area. So I think if someone has been going through our videos, this won't be that much of a challenge. So in terms of kinetic theory, you look at this guy, Brownian motion. You shall look at this guy, Brownian motion. Then you shall also have, like, let's say, other experiments where you can look at, let's say, sugar dissolving in a liquid and the like. All those are under kinetic theory of matter. Now let's now solve. So we're just going straight to the question. So what are the bright specks? What are the bright specks? Definitely we know these bright specks are smoke particles. smoke particles are the bright specks. So what you have there is a smoke cell. So definitely it's filled up with smoke particles. So these guys are colliding with light and air molecules. These guys are colliding with light and air molecules. So the reason why we are using light is because we want to see a reflection of these guys under your microscope. So light hits these, and so there's light, of course, hitting the smoke particles, which are colliding with the air particles, like that. So therefore, these guys will form a zigzag motion. Like that. This. So there's a collision between light, smoke, and air particles, like that. So definitely these are bright specks are smoke particles. So like I said, just go through the chemistry video on kinetic theory of matter. I think we did it before we did separation technique. Go to, I think it should be topic number, I think number 2, somewhere there. But it's there in the videos. Just check to one of the videos. So why are they bright specks dancing about? Why are they bright specks dancing about? So like I said, the smoke particles collide with the air particles in the smoke cell, as well as light particles. So these guys are colliding with air particles as well as light particles. So this forms a zigzag motion. This makes them move in a zigzag motion. So this makes them move in a zigzag motion. So you can hit each one. So this causes them to move in a zigzag motion, like that. So this causes these guys to move in a zigzag motion. This causes this guy to move in a zigzag motion. Like that. So we are finding the conclusion that can be made from this. What's the conclusion that can be made from this? So the conclusion is easy and straightforward. So we write the conclusion on the other side. Let's see, of course. So when particles of any substance collide, there will be a change in direction the change in direction for both particles. So in terms of this one, we had smoke cells, which were just fine. Smoke particles in the smoke cell, which collided with air particles. And light was our witness, of course. Light rays were our witness in inverted commas. So these guys collided, and this guy was used as a reflector to the microscope. So when two particles collide, definitely there will be a change in the direction. One of these, like that. So this is what you guys can deduce on this. So if you want to know more about this experiment, we've done it. So just check in the chemistry videos, because I know that if you guys are doing physics, that means you're definitely doing chemistry. So just check our videos. So we go to number 4. So probably number 4 will be our last one. It's not the second last. Then we can close this. Then we can close this. So number 4. So it's 2009 and we are number 4. So what we have there is bath, of course. We have a bath. We have a bath. We have a bath definitely. So for that bath, they are asking us to state 3 modifications that can be made for this guy to be more stable. 3 modifications that can be made for this guy to be more stable. 3 modifications that can be made for this guy to be stable. So definitely this is under stability. So mostly if you guys have got something that is not stable, the thing that you guys are looking at mostly is number 4. Looking at the best, then you will also be looking at the center of mass or the center of gravity. So you'll be looking at 2 things. So you'll be looking at base, and you'll be looking at the center of gravity. 2 things. So definitely, how do these guys link? Definitely, if something is to be stable, that means it must have a wider base. So it must have a wider base. The base must be wide. Wider base. And it must have a lower center of mass or gravity. So definitely the base must be wider than the center of gravity must be lower. So we have a triangle here. So this has got a wider base. This has a wider base. But if, for example, you had a shape which is something like this, so definitely this guy is more stable than this one. Why? This one has a wider base. Then, if you guys are looking at center of mass, so center of mass, this is where all the mass, this is where all the mass in an object is concentrated. Why it's concentrated? Concentrated. That's where there's your center of mass. So let me just show you using a simple diagram, because I don't just want to solve this, but I want you guys to have an idea of what I am talking about. So we shall look at this again. In terms of a regular shape, finding the center of mass is very easy. You just make a diagonal, then definitely that is your center of mass. It's the middle part, of course. Then, if something is not regular shaped, you can use other ways. So definitely you can drill 3 holes, like they should be evenly spaced. 3 holes. So for example, this guy. So I'm trying to solve and teach at the same time. So let's say we have this guy, of course. We are finding the center of mass of that. So that is not regular. That is not regular. Therefore, if you guys are finding the center of mass, you just drill 3 evenly spaced holes. Like that. So what do you do? Put a needle there which must have a pump or a thread. If you put it there, definitely this guy will swing down here. Then you draw a line along the thread. Again, if you put it here, it will go down again. So you likely draw another line, let's say there, if it goes down. So put it there, this guy swings down. Put it there, this guy swings down. Put it there, this guy will swing down again. So most likely that will pass there. Definitely that would be your center of mass for this guy. Like that. So for this vehicle that we have, first of all, you can see the base is small. Definitely the base is small. Therefore, you can widen the base. Widen the base of this. Widen the base. So number 1, widen its base. Widen its base. Widen its base. So that's the answer for the first one, the first modification. Then you guys see that there's a luggage on top of the bus. There are luggages there. So since you have a mass there on top, that means the center of mass is at the top, or it's high, of course. That's why those buses way back, the double-decker buses, they are falling too much. Because why? The center of mass was increased or raised. So what do you do? So put or place the luggages. Place the luggages in the lower deck. In the lower deck of the bus. That's why for these big buses, you see that luggages are placed down. Then you guys will be on top. So all the luggages are always down. Then the next modification is very simple. So if you guys can look at the windscreen is small. So it's more like a window. So the driver cannot easily see what's happening on the other side. So widen the windscreen. Widen the windscreen. Widen the windscreen. So this will create a larger view for the driver. So that's what we have on this guy. So 3 modifications. So this was 4A. So we solve 4B. Then we'll definitely wind up. So we're just ending at 4B today. We're just ending at 4B today. Then we shall continue with this guy tomorrow. So an astronaut with a mass of 75 kg on Earth travels to the moon, whose gravitational field strength is 1.6 newtons per kg. What is meant by mass? So what is meant by mass? So in simple definition, mass is the quantity of matter contained in an object. Mass is the quantity of matter contained in a substance. Like that. So mass is the quantity of matter contained in a substance. Then they're asking, what is the weight? What is his weight on the moon? What is his weight on the moon? So we definitely know that what's given? Our mass is 75 kg. Then our G, of course, is a 1.6. Our G is a 1.6. Our G is a 1.6. So our G is 1.6. So 1.6 newtons per kg. So we have different G's for all planets. So what do we know? Weight is equal to mg. What's our mass? Our mass is 75 by what's our G? Our G is a 1.6. Therefore 75 by 1.6, that's 120 newtons. That's your weight. 120 newtons. That is your weight. 120 newtons. That is your weight. Newtons, that's your weight. So we shall definitely continue from number 5, then 6, then 7, then 8, then 9. Then we shall continue with section B later on, after we go through the topics. So what I'll be doing is that from each video I'll be posting 2 videos daily, or 2 lessons in the group. The other one will be for topics, then the other one will be for past papers. So definitely I'll be posting a video on the solutions of this guy. Then I'll also be posting videos on the topics. So this has been yours truly, Dr. P, and I am signing out.